Alright, this is all about completing the square, which is an algebra topic. We use it to solve quadratic equations. It's one way to do it. If you're really good at it, you can use it to derive the quadratic formula. You can also put conics into their standard form. So that's like dealing with circles, ellipses, hyperbolas, and such, or parabolas. The goal of completing the square is generally you take a quadratic expression, right? And a lot of times it's more useful to put it in the form something squared, right? And that's where the term square comes from, is from this list of examples here. It's called a binomial square, which is basically x plus some constant parentheses squared. And binomial is much more general than that, but this is the type of binomial squares that we deal with when completing a square. And just to show you, there's a few examples here, like x minus 1 parentheses squared. You have to multiply x minus 1 by itself. And when you FOIL that out, it gives you x squared minus 2x plus 1, right? X plus 2 parentheses squared is x squared plus 4x plus 4. X plus 3 parentheses squared equals x squared plus 6x plus 9. X minus 4 parentheses squared is x squared minus 8x plus 16. So if you're given some general expression, x plus 8 parentheses squared, you'll notice that there's a pattern here, right? If you start with this number inside the parentheses, basically you double it to get to the coefficient in front of the x, and then you square it to get to the constant, right? So that works here, right? You double 2, you get plus 4. You square it, you get 4. If you multiply negative 4 by 2, you get negative 8. And if you square it, you get plus 16. And that's really important because that's kind of like the basis of this whole strategy. So the pattern is we double h to get b, right? And we square h to get c. Right, which is great, except why would you ever need to do that? Well, a lot of times what they'll give you is stuff that's not exactly in this pattern, right? They'll give you something like x squared minus 8x minus 27, not plus 16. So what you do in those examples is the first step, what you'll do is you isolate just the first two terms, right, in the quadratic, right? So you should have something that is x squared plus bx, right? And you can either move the c onto the other side, or you can just kind of like leave a space so you can separate it out later. And if you'll notice, what we're trying to do, like the whole phrase completing the square means, like if you're given these first two terms, like for example, if you have x squared minus 8x, completing the square is just the process of figuring out what that last term needs to be, right? And obviously it can be a wide variety of things, not just these values, right? If I had like x squared minus, say like 24x, right? Then if I cut that in half, I would get 12, right? Negative 12. And then if I squared it, I would need to add a 144, right? And so that process involves dividing b by 2. Right? You square that number, right? And then you add to both sides, right? And that's basically what completing the square consists of. It's basically starting with something that's not in a perfect squared form, but by doing this, it does put you with a perfect square, and then you can rewrite those three terms as x plus h, whatever that h happens to be, parentheses squared. All right? And that's completing the square.